So now I will discuss some of the configuration on projective geometry. First one is the final plane. It has 7 points that lie on the 7 lines. It is the smallest possible example of a projective plane. So axioms or two distinct points are contained in a unique line. Two non-parallel lines intersect in a unique point. There exists 4 points such that no three are on the same line. In a projective plane, there are no parallel lines. A projective plane of order n has n squared plus n plus 1 points and lines, with n plus 1 points on each line and n plus 1 on each point. In an affine plane, given a line L and a point P not on L, there exists exactly one line through P that is parallel to L. An affine plane of order n has n squared points and n squared plus n lines, with n points on each line and n plus 1 lines on each point. In finite geometry, there are finite number of points. If the points are on the plane, the geometry is either affine or projective. In a configuration, there are k points on each line and r lines through each point. So now we will go to the example of a final plane. This is an order 4 of projective plane as well as 5 of 5 configuration. This is an example of a complicated projective plane. These small circles are the points and the wriggly objects are the lines. As you can see, the lines seem to intersect in lots of places, but the intersections only count at the points. With that caveat, you can see that any two points are on a unique line, and that any two lines intersect at unique point. Each of 21 points is an exactly 5 lines, and every one of the 21 line goes through 5 points.
So the next one is Pappus configuration. In geometry, the Pappus configuration is a configuration of 9 points and 9 lines in the Euclidean plane, with 3 points per line and 3 lines through each point.
So this is an example of a Pappus configuration. This configuration is named after Pappus of Alexandria. Pappus' hexagon theorem states that every two triples have collinear points capital A, B, C and small letter a, b, c, none of which lie on the intersection of two lines, can be completed to form a Pappus configuration by adding the 6 lines, which are line AB, line AB, line AC, line AC, line BC, and line BC. And their 3 intersection points are X, which is equals to line AB multiplied to line AB, Y is equals to line AC multiplied to line AC, and Z equals to line BC multiplied to line BC. These 3 intersection points of the opposite sides of the hexagon AB, CA, BC. According to Pappus' theorem, the resulting system of 9 points and 8 lines always has a neat line containing the 3 intersection points X, Y, and Z called the Pappus line. Last one I'm going to discuss about Greenbaum-Rigby configuration. In geometry, the Greenbaum Rigby configuration is a symmetric configuration consisting of 21 points and 21 lines, with 4 points on each line, and 4 lines through each point. The projective dual of this configuration, a system of points and lines with a point for every line on the configuration, and a line for every point, and with the same point line incidence, is the same configuration. The symmetry group of the configuration includes the symmetries that take any incident pair of points and lines to any other incident pair. The Grombaum-Rigby configuration is an example of polycyclic configuration, that is, a configuration with cyclic symmetry such that each orbit of points or lines has the same number of elements. Now, this is an example of a Grombaum-Rigby configuration. This be constructed from 7 points of a regular heptagon and its 14 interior diagonals. To complete the 21 points and lines of the configuration, this must be augmented by 14 more points and 7 more lines. The remaining 14 points of the configuration are the points where pairs of equal length diagonals of the heptagon cross each other. These form two smaller heptagons, one for each of the two lengths of diagonal. The sides of these smaller heptagons are the diagonals of the outer heptagon. Each of the two smaller heptagons has 14 diagonals, 7 of which are shared with the other smaller heptagon. The 7 shared diagonals are the remaining 7 lines of the configuration. And that would be all. Thank you.